So welcome back, everybody, to our next talk with Nick Black, Notcurses, making terminals do things that were never intended. And let me introduce himself quickly. Nick is a lifelong alien. He began programming on Atari 400 sometime during childhood, and with no one around to tell him better, developed an idiosyncratic, unorthodox style involving more inline assembly and literary allusions that strictly necessary, or perhaps even justifiable. He has since graduated several times from Georgia Institute of Technology and dropped out almost as many times. At approaching 40, he still managed to code about 10 hours a day, every day, ideally those free of the Daystar's malignant influence. He hopes to one day destroy the sun. He lives in Midtown Atlanta with a puffy pingun and several Orca. Nick exclusively used black IBM Mode M trackpoint 2 and 13 keyboards and will happily buy any that you might have laying around. Clack, clack, clack. So enjoy it.
Hello there, MiniDebConf 2. My name is Nick Black from Atlanta, Georgia, and I'm here to talk about terminal gaming for better or worse with my character graphics library, Notcurses. Our vaunted DPL, Jonathan Carter, reached out to me and asked if I'd want to talk about Notcurses in a gaming context. Now, I'm not a gamer. I beat NetHack in the May of 2018 after about 20 years of playing it. That's enough for me. I'm a compilers and HPC background. I'm an old school systems programmer. I did work at NVIDIA, but it was entirely in a compilers context. I work in a system programmer. I've developed a few TUIs and just wanted to push things a bit further than where you can with NCURSES. Now, Notcurses actually started with some palette fade routines I submitted to and had rejected from NCURSES, and a year later it's grown into something pretty unique and powerful. But what's the relevance to gaming? Well, in my opinion, Notcurses is the only game in town if you want serious graphics work in the terminal. But why would one want to game in the terminal? Well, it allows running over SSH and without extra Wayland. The dependency chain is probably going to be shorter than any serious GUI application, built atop GTK or KDE or WX widgets, pretty small. You might have existing text-based games, and using Notcurses, you can make them pop with images and video and effects. The myriad widgets built into Notcurses can allow you to really quickly whip up an interface for a game that you might want to do. So, having decided to do some terminal gaming, why wouldn't we just use the old workhorse that is NCURSES? The Curses API is everywhere. AIX to HPUX to Honeywell terminals to Honeybee terminals to Hazelton terminals, everything's there. It's well tested, and what more really is there to say about terminals after all these years? Well, for one, although it has some extensions, NCURSES is bound to the almost 50-year-old Curses API. I think around 76 or 78 is when that first came out. I feel about as old as a hacksaw can be myself, and I am not as old as Curses. Curses preceded 1989's ANSI ISO-C. Curses preceded 1988's IEEE 1003.1, aka POSIX. And it is a messy library of global variables, no namespaces or even identifier prefixes. I submitted a ZFX patch last year because they had a parameter named lines, which collides with a global variable from term.h. Curses doesn't specify its interaction with multiple threads, and its support for it wasn't designed with parallelism in mind. Its Unicode support is piecemeal, limited. The maximum UGC length is fixed at NCURSES compile time. It's built around a Baroque index color pair system that anybody who's done serious NCURSES programming has to admit leaves a lot to be desired. It's a phenomenal implementation. Thomas E. Dickey's fantastic maintainer, but showing its age. A great many successors to Curses. I tracked several dozen in a project repository documents. I haven't examined them all, but none of them had both C, multimedia capabilities, and being implemented atop term info. And some people want to bring up Sixel. Sixel on Linux is not really supported much anywhere that one would use outside of Xterm. It's not, to the best of my knowledge, in VTE, Alacrity, Kitty, Console, RST. In fact, Kitty has its own graphics protocol. We also do not support that one in the back end. If you rely on Sixel, it's difficult to naturally fall back to other blitters. So let's talk about the Notcurses drawing model, which is inspired by Curses and be pretty familiar to anybody who's done any graphical work or honestly even just thought about how one might. We've got a user visible rendering area that can change size at any time, at least in a terminal emulator in a Windows environment. Since we're writing a stream of characters to this terminal, overwriting or underwriting will just mess up our concept of geometry rather than being catastrophic. When we render, we solve for each cell of the rendering area and then compare each one to the cell that was last written to that coordinate. If they're different, we update the last frame and our terminal. All our drawing is done on virtual rectilinear areas known as NC planes. The standard plane, which comes by default, cannot be destroyed, rotated, spindled, folded, mutilated, or moved, is always sized and placed to match the visible area. Other planes can be manipulated pretty freely. Each plane belongs to one and only one stack. The standard plane is always part of the main stack, and only the main stack is rendered. There exists total Z ordering on the planes of the stack. Planes are made up of cells into which glyphs are printed. A glyph might take multiple cells, but only integer multiples ideally, and we'll see where that breaks down sometimes. In addition to a glyph, each cell can have an independent foreground color, an independent background color, and an independent style. The style can be, bold, italic, a combination of those, blank, and those are terminal limited, but most support a pretty standard set taken from ECMA 48 and ANSI, etc. In Notcurses, each of these three channels can independently be transparent, and in addition, the colors can be translucent. So here's a bit more detail, visual representation. In the lower right over here, we see the Z-axis of the main stack. Here we have 4 planes, standard plane and 3 user-created ones. In addition, the Notcurses context has its plane containing the current concept of the visible area over there on the lower left. Each plane is backed by a cell matrix, a rectilinear array of cell structs. In the code, this is sometimes referred to as a frame buffer. Finally, while our Unicode UGCs can usually be inlined directly into a cell structure, longer UGCs must be spilled out to the backing EGC pool. There's one of these per plane. They can grow to 16 megabytes. That comes from a 24-bit pointer that's inlined into that cell struct. Another data structure we'll see a lot of are NC visuals, which are basically RGB pixel arrays loaded from a file or memory or even from a plane, actually. And these they are not associated with a particular plane, but they can be blitted onto one or more for each one of those visuals. So that is what supports entire Notcurses context, and there's going to be one Notcurses context per terminal on which you are operating. It might be worth to take a moment to talk about EGC pools versus EGCs. Every Unicode character currently defined can be UTF-8 encoded in 4 bytes or fewer. An EGC cannot necessarily be defined in 4 or fewer bytes, but any single character can. So this seems pretty solid. We can rock with it. What are the problems? Well, first off, our resolution, the total number of effective pixels, is garbage. My monitor here is 3440 by 1440. Mid-90s SVGA was 800 by 600. Your friend of mine, the Nintendo Entertainment System, introduced in 1985, did roughly 256 by 240, 256 by 224, depending on who you talk to. A typical terminal geometry might be, say, 80 columns by 75 lines. Now, Notcurses can give you twice or more effective resolution in both dimensions, but you'll never have the broad vista of a pixel frame buffer. Now, with that said, the Super Nintendo had essentially the same resolution as the NES at that 256-240 in its default modes, but it looked much, much better. And this was due to the Super Nintendo's ability to use many more colors at once. We have 3 full 8-bit channels of fun at our disposal, so let's not embarrass ourselves. We're drawing with irregular asymmetric glyphs, and we can't get information about whether the appropriate glyphs can even be rendered, let alone how they might combine or their precise shape. Now, here's an example of this very real font problem. This is a bit of a worst case, but it did come up naturally during Notcurses development. Let's draw the 5 wide Unicode characters, circled number 40, 50, etc. on black square, one after the other. We might assume this would consume 5 times n columns, probably n equals 2 is 10, and that they'll be evenly spaced. Well, no, we can't assume that at all. Our world is a wretched one. Alacrity printed nothing. Kitty printed characters much smaller than most. Xterm just printed empty boxes. VT generated an unreadable mess. Consoles slightly overlapped each, just wrong enough to be almost completely useless. Suckless Terminal got it right, so good job, Suckless Terminal. By the way, this is way better than any of them were doing 6 months ago, by the way. You can go take a look at Notcurses issue 881, I think filed up and finished in August, to see how this whole messy endeavor went down. It was unpleasant. So how do we take an RGBA visual and render it to cells? Notcurses offers several blitters, each using different set of glyphs to affect different geometries. Without UTF-8 restricted to ASCII, the only meaningful method is to use a space per pixel. Set the background to the pixel color. This has aspect ratio problems, and it minimizes our effective resolution. We only get what the terminal offers us. One step up is the method of half blocks. This is kind of the state of the art. You see it in MPV's TCT output, VIU, the Rust program. Someone pops up on Reddit about once a week having invented it. This gives you a perfect 1-to-1 aspect ratio and lossless pixel representation. You have 2 colors and you're representing 2 pixels. Notcurses offers 2 blitters beyond this that I haven't seen anywhere else. Quadblitter uses Unicode quadrant glyphs, the upper and lower half blocks of the previous blitter, and the left and right half blocks. Sexblitter uses the new sextant glyphs of Unicode 13 for 3 times the effective vertical resolution and twice the effective horizontal resolution. Usually these are going to be superior to the half block blitter, but they do fundamentally lerp between pixels in certain configurations and thus lose information. If you have a minimal number of colors, they are going to be the best choices that you can proceed with. Right now, 2x2 is the default because there's bad font support for sextants. If we make the font small enough, we can of course effectively use pixels. That's cheating, though. You can't read glyphs at this size, so you lose your TUI elements, and it's far less efficient than using a proper pixel interface like OpenGL, so this isn't really too useful in practice. With that said, we can do some pretty cool proofs of concept with this setup. Here's Nestopia playing through Notcurses. So what I've done here is I've gone ahead and shrunk my font down to, I think, 4 point. I've patched up Nestopia to use Notcurses as its blitter. I'm using the NG-Blit BGRX routines as its core, and works pretty well, but again, kind of bullshit. Now, I don't want to just walk you through the manual pages, of which there are a complete set, by the way. So let's go ahead and build a little something, in the words of the judge of Cormac McCarthy's Blood and Meridian, see what manner of thing we have here. So we've got 30 minutes, and we've got a terminal. I've already grabbed some media that we're going to use for our little experiment, and thought about what I wanted to do, but had not actually coded it up. And so watch, you might learn something, you can laugh at my mistakes, and I'll be annotating this, providing live commentary as we go. So without further ado, here is debwarrior. So I've grabbed 7 media files from various places. We've got 4 4-frame animated GIFs from Final Fantasy III covering Celes's walking cycle when facing the 4 distinct cardinal directions. We've got our debwarrior logo, you just saw, which is just the warrior from Dragon Warrior, along with the Debian swirl. From Final Fantasy I, we've got the bitmap for Warmech and the Overworld map at 4096 by 4096 pixels. Final Fantasy was, of course, the last fantasy from Square Enix, a company from which we never heard again. Note that all of these images, save the Overworld map, have transparent backgrounds, which is critical. Bitmaps plus transparencies equals sprites. So it's ideal and almost critical for Notcurses to run in a UTF-8 environment. That means that a UTF-8 locale has been generated and made available on Debian, that's via dpackage reconfigure locales, and that the lang environment variable has been properly defined to reference it. This is generally done by your installer nowadays, but be prepared to have to handle this yourself in, e.g., a minimal Docker environment. If you're not getting good blitting results, this is almost always your problem. Usually, almost every C or C++ program might be calling set locales its first line or very soon after. Despite it being 2020, many people still don't seem to know this. Notcurses will call set locale for you if it detects an encoding other than UTF-8, and you haven't provided the flag inhibiting this behavior. But that doesn't help if no good locales exist, or if you don't happen to have one specified in lang. Here, we're going to go ahead and let Notcurses handle things for us and move directly onto the Notcurses init call. Now, Notcurses init determines whether or not it's actually talking to a terminal, since you could be, for instance, redirecting to a file or any number of other things. And if so, it initializes the term info database based on your term environment variable. This is the second aspect of your environment that needs to be properly set up. And by that, I mean your user's environment. Without a term variable, or more annoyingly, with an incorrect one, Notcurses won't know the proper protocol to speak to your terminal, nor your terminal's capabilities. Now, if your term is xterm, if your term variable is xterm, you need to be running xterm. If your term is VT100, then you should be on a physical VT100, and you're probably not. So you need to be picking the correct term variable for the actual terminal emulator that you're running. Notcurses is more sensitive to this than many other applications because it makes such aggressive use of the terminal. If you're getting weird cruft or strange errors, but things mainly seem to work, the term variable is one of the first things to check. So as mentioned before, NC visuals are RGBA bitmaps that we can load from various sources. We're going to use NC scale stretch here to use the entirety of the target plane's area when we blit down to it. There's also NC scale none, which blits the source bit perfectly, and NC scale scale, which retains aspect ratio while otherwise scaling as large as possible given the target plane. And these scalings are performed borrowing the multimedia library, either FFmpeg or OpenImageIO. They can shrink an image since they're bound by the target plane's size. We'll use NC scale none with our overworld map, and that means it's actually going to be 4096 by 4096 cells if we were using one-to-one scaling, one-to-one blending, far larger than what we could ever fit onto our terminal. For our intro logo, however, we want the terminal area, all of it, no more, no less. We're going to fade this logo in over the course of a second. Were we loading a great many textures or doing other large-scale work, we'd likely want to start a background thread to begin those tasks during this fade. But nothing we're going to do here in debwarrior is likely to incur any perceivable latency, so we don't bother. When the fade ends, we throw up a prompt and then wait for the user to press enter. While we're waiting, it's important to note that we're not doing any work. There's no need to constantly render frames, and we won't be incurring any CPU load. So let's go ahead and prepare our overworld map. We're going to request the sex blitter via NCBlit 3x2, but we might not be able to use it. For instance, we might be in an ASCII-only environment due to lang not being set, or some other reason, or in a situation where the font support is known to be lacking, for instance, the Linux console. There's a flag that can cause NC Visual Render to fail out if we can't get the desired blitter, but in the name of flexibility, we want to continue to work, even in a graded fashion, so we'll forgo that. Unfortunately, we're going to need to refer to some absolute locations on the map. The first example would be initial placement of our player character, and we don't know exactly how many target cells map to a source pixel since we don't know ahead of time exactly which blitter we're going to get. The NC Visual Geom call remedies this ignorance. It lets us know exactly how many pixels rendered media will require and the ratio of source to destination. If we get NC Blit 3x2 as requested, remember that was 4096 by 4096, that's 2 to the 14th by 2 to the 14th. 2y will be 3. 2x will be 2, and that means our 4096 by 4096 map is going to be 1366 rows by 2048 columns. Meanwhile, our 16 by 24 pixel player graphs then become 8 columns wide and 5 1/3 rows tall. Now, can you write 1/3 of a row? No, you cannot. But Notcurses manages the 2D occlusion of stacked planes for you, and the results are what you'd expect. So if we are only taking that top third of a cell with our player character, the bottom 2/3 are going to be the color that is assigned by a lower plane. In a real game, we'd almost certainly not be loading the map as an image. For any number of reasons, it would be more useful to store tiles and then index regions into those tiles. One reason would be file size, especially given the 144 kilobyte ROM cartridge on which Final Fantasy was sold. Let's do some quick analysis. Overworld map is composed from 16 by 16 tile areas, leading to a world that's 256 tiles on the side. That's 65k total tiles of area. There are no more than 128 distinct tiles making up this map. So to byte per pixel, remember NES was palette index color, that's 32 KB of tiles and 57 KB of tile indexing, 65K times 7 bits, for a total of about 90 KB. The actual bitmap would be 16 megabytes uncompressed, 8 megabytes using a 4-bit palette. The 16 megabytes is an 8-bit palette. The actual PNG we're loading is about 330 KB. So you can look at PNG as either a 96% half-full reduction of the true bitmap size or a 3.6 half-empty blow-up of a trivial, if situation-specific, compression scheme. We'll be showing hit points and any other stats that we want to maintain for this limited proof of concept, just hit points, at all times. We're going to go ahead and keep them at their own plane up at the top, and we'll call update stats whenever we need to change that up. Since the stat change would almost always be going along with some other action, we don't go ahead and render within there, since we're going to come up presumably by whatever called it. Now, for Celeste. Remember that we have 4 distinct files. Each of them is a 4-frame animated GIF of the walk cycle in one of 4 directions. If you remember the player definition from up above, we'll read each one of these files into its own NC visual and create for each one of those NC visuals an NC plane. So each NC visual will be rendering to one plane only. Only one at a time is going to be above the map, z-axis wise. The other 3 will remain below it and will be invisible to the user. Other ways we can manage that would be keeping them off screen, i.e. to the above and to the left of the origin of the visible area. We could use one unified plane for all 4 visuals and bullet each one onto there, erasing each time. Probably was the best way to do it. Would save memory as well. Or move them onto their own stack, the ones which aren't being used. Stacks were added late in Notcurses development. The last 2 options would technically be the most efficient, but the difference for 3 planes, especially small planes, is going to be almost certainly negligible. Why that is comes down to details of the rendering algorithm. If you can each proceeding down through the various planes from the upper left to the lower right, finding cells that haven't been solved yet. Anything that is below an opaque plane that spans the entirety of the visual area is never going to be rendered because by that point all cells have been solved. Something that's above and to the left is going to be looked at, but then the cells aren't going to be selected since they're not meaningful for the rendering area. And something that's off on its own stack is never going to get rendered, touched by rendering at all. To center a plane, like we're doing here, we just need to go ahead and get the dimensions of the plane that we're centering it on and the dimensions of the plane we're centering. We divide both by 2 and subtract the latter from the former. Easy peasy. Technically that NC plane dim YX wasn't necessary given that I did the NC dims inline right after. Won't cause any problems, it's all good. Once we've initialized everything, our main input loop is going to be based around a pretty simple idea of render the next frame of the player's walking cycle, then wait for a navigation key to come in. We'll support the arrow keys as well as the VI keys. Notcurses also provides support for mice, so if we want to enable some kind of RTS-style mouse-driven movement around the map, that wouldn't be difficult at all. So first we're going to call the load Celeste function that we just defined above, the one that loads the NC visuals and NC planes. Now we need to figure out where she is going to go on this map. And you know what that means. Bring out the GIMP. So, the GNU image manipulation tool. Now, like the real Final Fantasy, we're going to want to stick her immediately south of Castle Caneria. We get the coordinates, adjust them for the player size, scale them by the blitters 2y and 2x. I really ought to have scaled her dimensions by 2y and 2x as well, alas. And we're going to place the map according to this location. We're never actually moving Celeste, who always remains at the center of the screen. We're simply moving the map behind her. The map's coordinates are almost always going to be negative values, since when it's at the visual area's origin, we're at the very northwest corner of the map. When it's at its minimum values, position-wise, and those would be 2 substantial negative numbers, that's when we're at the southeast corner. Have these, and we are at the center of the map. So we've got this map Y. Going to go ahead and do something very similar for map X. Taking these initial coordinates, and once again it's ones we pulled, and then we modify them by the actual player character size. Once we've done that, we're going to want to move the map to its starting location. We are going to want to go ahead and set her direction variable up to be facing down. That's where she's looking at the beginning. We then bring that appropriate plane up to the top above the map, and we're going to do a render to initially set things up before we get the first character. When we've just pressed enter, the screen's been shown, and now we start going ahead and actually getting interaction from the user. So, what are we going to do in the guts of this input loop? Well, first take the plane that we just rendered, move it down to the bottom. This isn't going to be immediately reflected because we don't have a render call there. Once the input is processed, we're going to move the map to its next location. We're going to advance the player by which, you'll see, we're going to take the proper glyph and bring it up to the top and update stats and all that. Check to see if we're in a battle situation, and at the very end, render. Now our input loop is going to be a 6-way loop. Q is handled to exit the game. Other than that, we're going to need 4 of them for each direction that we can be moving in. Each one is going to change the map coordinates and set the direction variable appropriately. Now, as you're going to see here, I have, again, failed to scale by 2y and 2x as I ought have. Instead, I'm just using the constants 8 and 5, which we get from the player glyph size, player sprite size, rather. Had 3 and 2 not have been available, this would lead to some problems. We would be moving too far or too little for each input stroke. So that's an error on my part. Caught it afterwards. And so it goes. Now these boundary conditions are going to need to be checked once we've done this update. We're going to need to check to see whether we are greater than 0 or less than the maximum map size. And here, once again, I've screwed up, and you're going to see I used the hard coordinates of negative 2048, and that is just fundamentally broken, given that if we get 3 by 2, we are not going to have 20 by 48, we're going to have 1844, as said earlier. So that is an error here. And furthermore, not really an error, but an inefficiency, really should have gone ahead and put these boundary checks up in the appropriate conditionals rather than at the bottom. If we've just moved up from a valid location, we can't have moved left off the screen as a result of that. So we're executing a bit more conditional code than we need to. You'll also note that we check for NC key resize. That's what we get when the sig winch signal, that's a signal window change, has been handled. Notcurses installs a default handler for sig winch, and then when it sees that the terminal has been resized, we get that input key so that we know we should probably go ahead and update our concept of the screen geometry. And that's exactly what we do. Notcurses refresh also then repaints the screen knowing the correct new geometry. So that's what that did. Now advanced player, which we called from below, NC visual decode loop. This is used to get the next frame. If we're taking a left and then another left and another left, so we're not changing which plane is up at the top, we want to be iterating through those 4 frames of her walking cycle. That's exactly what NC Visual Decode Loop does. It takes you down through the last one and then takes you back to the first if you call it again. So we go ahead and move the new one to the top after decoding it. We update our stats, and now let's go ahead and try build. And you get to watch me mess around for a minute as I fix up various syntax errors and other stupidities. We didn't include the Notcurses overall context struct inside player like I had meant to. So it is. And, this will be a bit painful to watch, but as said, while I'm not providing this commentary live, the coding was done all in one shot. You're seeing everything I did. So, read the man page, figure out what's going on. Don't worry, it's pretty short. Oh yeah, need to actually erase that and then actually call render. That's why we're getting an unused variable. So thank you, compiler, for catching that for us. It's much appreciated. Go ahead and do the render. The erase is necessary because even though it has a transparent background, if you just tried to re-render, any pixels that are not covered by the new one, since it's transparent, they're not going to be updated. And eventually you would have kind of a snow angel. You would have the maximum set of glyphs that any frame in the walking cycle had touched. So, small detail, but an important one. Alright, so we need to go ahead and change that from an NC visual to an NC plane, and I believe following that we are back in business. We'll just have a missing function, and we will proceed from there. All right, here we go. So now that we can hopefully render and move around on the map surface, let's go ahead and implement overworld battles. Again, given time constraints, we'll be working at a proof of concept level. So let's go ahead and assign a 1 in 30 probability of encountering an enemy. In a real game, this would likely be dependent on our location and the composition of the enemies we're meeting surely would. We're just going to deal with one static enemy here, the much-feared Warmech. If you played the original Final Fantasy, I think you had a 1 in 64 chance of encountering him on your way across the bridge in Tiamat's Sky Castle. Maybe not. I mean, that's, I believe, what the Nintendo Power Strategy Guide informed us of anyway. So we're going to load up his bitmap after making a copy of the map, and we're going to set that copy to grayscale so that it doesn't distract from the fight scene, but it still gives us localized background where we were. It's not jarring when we switch back and forth from it. Since this copy is going to be opaque and atop the map plane, the latter will be entirely obscured by the former. And once the fight is done, we'll destroy this copy of the plane and be right back where we started. We want the enemy to take up about 3/4 of the total height of the screen, so here I'm going to divide out by 4 and multiply by 3. I should have done those in the reverse order to achieve higher accuracy. You can kind of obviously see how that would happen, given that C throws away any decimal part when it does integer division. Oh well. So it goes. We're going to set up the enemy's the enemy plane's base cell transparent. Now, the base cell is used in rendering calculations whenever the plane is otherwise undefined. So this will ensure that our irregularly shaped enemy doesn't obscure the background in its rectilinear plane where it needs to do so. Our primary control for battle mode will be a scrolling action selector on the bottom left. For now, we are going to go ahead and define 4 actions that we can take. We can cast a spell, we can vomit intensely, we can run away, or, as one does when encountering strange mechanisms of unknown danger, we can package it in the AUR. Now, we define our selector options up using the title action and create the selector using these options in our defined plane. By now, you probably see a pattern. We create and configure a plane, we define options for a more complex structure, we associate that structure with the plane, and then we render. We've done it with NC visuals, and now we're doing it with NC selectors, and this is done a lot when writing in Notcurses programs. There are, of course, many other things one can do with planes, as you've seen, printing strings to them, formatted output, free flow, laid out output, etc. But this is what we're doing when we work with the more complex widgets. We go ahead and set the base character for our selector and also for the main dialogue NC plane plot P to black and almost black. They're going to be opaque so that they're easier to read, given that they're primarily text. With everything set up, we move into the battle loop proper, where we're going to loop until our player runs out of HP and or defeats the dreaded mech. Now, since our player isn't actually going to be able to inflict damage in this proof of concept, there's really only one sad way out for them. So here again, we're going to have an input loop, and this is our first use of an offer input function here, NC selector offer input. In this case, essentially, since we're driving the input loop ourselves and we don't want rendering going on while we're messing with the context, we've got to handle input that's intended for widgets like the selector. We can hand code it all by ourselves, and that is exactly what we would do if we wanted to customize the behavior of a widget. But instead, we can just gracefully offer up the input to the widget itself and see if it wants to handle it, and so we don't need to do anything. This achieves all of our scrolling, etc. within the selector. All we handle is the NC key enter case, and we handle all of them the same way. The action is ineffective, FYL. In a real implementation, of course, we would then query the NC selector for which one was currently selected, and then perform some action specific to that. Following this, Warmac attacks us each round with the fearsome nuke, and we update our stats, possibly dying along the way. So let's build. So there you have it. We just built, the backbone at least of a Super Nintendo quality game. Runs entirely in a POSIX terminal, and it worked. Didn't take too long to build. I hope you enjoyed that, and I hope you build something with it. Future directions in Notcurses. I started this a year ago, November 11th, 2019. It's been a good year, but other things I still want to do to it. The biggest annoyance I feel when developing is geometry changes that can come from nowhere, and they're annoying to deal with. I'd like to get us to where we can almost automatically handle all of them. By using the reflow text engine, we can then just reflow it. If planes are declared as aligned relative to others, we can handle that automatically. And I want to move to a declarative model, for kind of an old Visual Basic model almost, to make programming easier and to handle that better. I want to convert RGB. RGB escapes are about 12 bytes apiece, whereas a palette index tends to only be 1 byte. And where we are using fewer than 256 colors, I'd like to squash all the RGB down into a palette, program that, and then use the lower bandwidth equivalent. I'd like to handle input a bit better. Supporting PTY in a PTY, where basically we can run another TUI program within a sub-window, VSync and gamma correction, maybe, and I'd like to improve on our current painter's algorithm just to improve speed, but really performance is pretty great. You can average around, on my computer at least, 4,000 to 5,000 frames per second, far better than any actual output device that's out there. So, I'll now take questions. This presentation has been dedicated to Thomas E. Dickey, the long-suffering maintainer of NCURSES and XTerm. He writes superb engineering history. Go read his facts. Go for it. What questions you got? Thank you for having me here, Debian.
Henry?
Thanks a lot for your talk, Nick. It was impressive.
I hope you enjoyed.
Yes, absolutely. So now let's go to our questions. The first one is, does Notcurses work correctly in screen tmux as they override term to more generic values that no longer match the actual terminal?
Scream and tmux are somewhat annoying. So I've actually got a document in the repository, terms.md, which goes through all the various terminals that I test with and gets into what they can support, what's wonky on them. Screen and tmux are certainly challenges. We do not look as good in them as I would like to. And how exactly to overcome that is an interesting question. As you say, they do rewrite the term, and they rewrite it to one that's pretty downgraded. I believe that only Screen 5.0 plus has support, for instance, for true color. If you're using Screen 4, which I believe is the one shipped in Debian Unstable at the moment, then you're only going to get a much more limited color palette. Whether we could reach beyond there is doubtful, given that they are going to be reinterpreting control sequences that we send to them. So I'm not exactly sure what we can best do in them. They're still not the worst. The Linux console, the true virtual console, has even less impressive capabilities than your typical generic screen. Now, one thing that Notcurses is going to do soon is implement what I call PTY and a PTY, whereas much like Screen, we are going to be opening up a term that then will be dynamically populated, and we will be able to map into the one that we are actually connected to. And that'll be useful, for instance, if you want to run one program that uses NCURSES or Notcurses within another one. That's PTY and a PTY. Whether or not that's going to work as well as I would hope, I'm unsure. The test program will be, I want to take Linux perf, and I want to be able to run a program inside of a Notcurses window, get live perf sampling, and be able to do histograms and such as it's going. So, hey, here are your branch miss predictions by time. Here are your L1 cache misses by time. We'll see how it goes.
Okay, the next one. We are impressed by the speed and intensity that you code during this session. When you say you code 10 hours a day every day, is it usually like this, or do you sometimes work at a more relaxed pace too?
No, that is about opto, sir.
follow up.
You don't oftentimes get to work with a library that you have been you're not only the author of, but have been spending almost all of your free time on for the past year. I don't think that I could code much anything else that quickly. Most of my professional day is spent at Microsoft trying to deal with everything Microsoft throws at me, and it doesn't go that quickly at all, I assure you. As for whether it was sped up, I used Kdenlive to make this. The setting on that was 102%. It had a slight speed up in order to cut it down into the format. So I believe that as opposed to 26 minutes, it was something like around 27 or so. Right up there. I wasn't trying to brag with typing speed. I was just trying to get something pumped out. Yeah, I think that answers your question.
Yeah, follow up. Did you speed up the coding clip at all? We are just
that's what I was saying. It was set at 102% in Kdenlive. So I think it was 25 minutes in this video. I think it was between 26 and 27 normally. I also cut out, I think, a 4-minute section of nothing going on. So me answering my front door. That was cut out. Okay. So that's that was the editing that went into it.
Got it. Okay. Does it have mouse support?
It absolutely does. Not only does it have mouse support, it has it in both the Linux console and X. If you have GPM set up in the Linux console, that's the General Protocol Mouse, I believe is what that stands for. Not only can you use it in full screen mode, but we didn't talk about this, but there's what I call direct mode, which is a line-oriented one. I kind of call it stylizing your printfs. That's when you still want to use standard I/O, but you want to be able to color it or do other things. I even support a mouse in that environment. So yeah, you've got mouse everywhere. If you do scroll wheel, it supports that. Yeah, pretty much anything that can come over an X input device and be measured in coordinates, yes. And there's a Notcurses. Oh, sorry, you asked?
Yes, finally, there is a Notcurses Rust crate. Which other programming languages are support?
Yeah, the Rust crate is due to my Spanish comrade, Jose Luis. He is a great guy, and he's done a real good job with that. I was trying to do it at first, but he stepped in and did a great job. There's a C++ wrapper by my Microsoft comrade from Poland, Marek Habersack, similarly done really well. I asked him, hey, I just want a very thin wrapper on top of this. I want both an exception and a non-exceptions mode, and he came back with it done pretty much perfectly. There is also a Python wrapper that I implemented that is not very good. I'm not a Python expert, and it's not code that I'm proud of. Thankfully, I got a PR about a week ago from a Russian friend, and it is a much better Python implementation. Mine was based on CFFI. His is based on a different method. I can't recall it right now, but hopefully that's going to be merged in, and you should see that in the next release. As for other wrappers, I will welcome any that want to come in, whether you want them in the main Notcurses repository or to run a sister repository. I accept maybe not even let Java in. Why not? More the merrier. I'm not writing it.
Okay, our last question. Any interesting games, applications that are using Notcurses that you want to check out?
Because, I had two large NCURSES programs that I had written this decade. One is one just went into Debian, actually. It's called Growlight, and it's a visual block device / file system editor. There's one that is not in Debian and isn't, I'd say, really ready for general use, called Omphalos. It's a network enumeration / domination tool. So both of those were ported over to Notcurses, and they were kind of the motivator for getting it done. I was very excited recently to see that there's another Debian package, SND, a sound editor, by a fellow out in Stanford, and that is using Notcurses. Aside from that, I do news searches for it regularly, so I see people who are picking it out. The 1.x series was very heavily flexing in terms of API, and so a few brave people signed on. I kind of said, hey, you might want to wait until 2.0 when that stabilizes up. So I'm hoping to, and it's also a chicken and egg problem of, is it out in the distribution? So now that it's getting out there, I'm hoping to see people pick it up. If they don't, then they shan't. But yeah, I'm working later on a SDR program that'll use Notcurses. SDR, software-defined radio. If you want to run it remotely, which one oftentimes does, it's a tremendous amount of data to bring back. You typically want to do your visualization on another server if you can, but hey, with X11 forwarding, that doesn't tend to work well outside of a LAN. So hoping to do something there that will improve that situation for people.
Great. Thanks a lot, Nick.
Thank you for having me, Debian.